Error detection in data transmission, IC and USB. Error detection and correction in data transmission. In data transmission, during the transfer of data, noise and other impairments are introduced. The methods used for detection of these is known as error detection. Error detection helps in data's reliable delivery across channels. It also helps in reducing the undetected error probability, that is the transfer of incorrect frames. Some kind of algorithm is applied before the transmission of data to produce an error detection code that is usually sent over the channel with the data. The receiver applies the same algorithm and generates error code from the received data, then compares it with the error code generated at the sender's end. If both codes are the same, then it means the data received is error-free. Otherwise, the received data is considered incorrect and the receiver acts accordingly. How parity bits are used for error detection. Data transfer also encounters noise and impairments that alter the digital signal. For example, data sent 1001 can be received as 1101. To detect this type of error, the parity bit can be used. Parity bit system can be even or odd, and it is the introduction of one additional bit at the start or end of the bit stream transmitted. In even parity system, the number of occurrences of ones needs to be even and decide whether parity bit should be 0 or 1. However, in an odd parity system, the number of occurrences of ones needs to be odd and decide the value of the parity bit. Integrated circuit IC. In the initial time, data was sent in serial form, that is one bit at a time over a single channel. With the advent of technology, integrated circuit introduced and allowed multiple devices on a single silicon chip. Because of it, the parallel transmission of data came into existence. Conventionally, it uses the transfer of a byte, that is 8 bits, simultaneously, making the transfer of data faster. The standard parallel interface uses a 36-wire heavy cable that was also expensive. Today, many ICs make use of serial and parallel data transmission. One example of IC is multiplexer, that is also known as MUX. It utilizes both serial and parallel interface. It is a combinational logic circuit. It is used to switch multiple input signal lines to a single output line using a control signal. It works as a multiple position rotatory switch that is very fast. The input lines are also known as channels. It can be digital using logic gates or analogous using transistors, relays or MOSFET. Universal Serial Bus USB. It uses an asynchronous method for data transmission. It has been widely used today for the transfer of data from the computer to multiple devices. USB cable typically consists of 4-wire shielded cable. 2 used for data transfer and the other 2 used for power and on. USB is detected automatically by the computer system. The system is then recognized and the required driver is installed automatically. Around 127 devices can be connected to a single USB port using a USB hub. If you like this video, don't forget to like us on Facebook, follow us on Instagram and LinkedIn, and subscribe to our YouTube channel.